ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಇಂಟೆಗ್ರಲ್ ಕ್ಯಾಲ್ಕುಲಸ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಏರಿಯಾ ಬೌಂಡೆಡ್ ಬೈ ಎ ಕರ್ವ್. ಸೊ ಯೂಸಿಂಗ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಇಂಟಿಗ್ರೇಷನ್, ಹೌ ವಿ ಕ್ಯಾನ್ ಡಿಟರ್ಮೈನ್ ದಿ ಏರಿಯಾ ಬೌಂಡೆಡ್ ಬೈ ದಿ ಕರ್ವ್, ದಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ಹಿಯರ್. ಸೊ ಇಲ್ಲಿ ಎರಡು ಥರದ ಕರ್ವ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತಾ ಇದ್ದೀವಿ. ಒಂದು y ಈಕ್ವಲ್ ಟು ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಅಂತಂದರೆ ಕಾರ್ಟೇಷಿಯನ್ ಕರ್ವ್, ಇನ್ನೊಂದು ಆರ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಆಫ್ ಥೀಟಾ ಅಂದರೆ ಪೋಲಾರ್ ಕರ್ವ್. ಸೊ y ಈಕ್ವಲ್ ಟು ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಅಂತ ಬಂದಾಗ ಇದು ಈ ಥರ ಕೇಸ್ ಬರುತ್ತೆ. ಇಲ್ಲಿ y ಆಕ್ಸಿಸ್ ಇದೆ ಮತ್ತು ಇಲ್ಲಿ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಇದೆ. ಸೊ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಮತ್ತು y ಆಕ್ಸಿಸ್ ಆ್ಯಂಡ್ ಬಿಟ್ವೀನ್ two ordinates a and b. So here is the curve, graph of the curve y equal to f of x. So the area bounded by this curve between the ordinates a and b. So this area we have to determine. Okay. So this was given by integral a to b f of x dx ಅಥವಾ integral a to b y dx. This is the case of Cartesian curve. So polar curve ಅಂತ ಬಂದಾಗ area bounded by two lines corresponding to two different angles. So area ಇದು ಬರುತ್ತೆ ಇಲ್ಲಿ, ಈ ಏರಿಯಾ ಕಂಡುಹಿಡಿಯಬೇಕಾಗುತ್ತೆ. So for this the formula is a equal to integral theta 1 to theta 2 1 by 2 r square d theta. ಸೊ ಇಲ್ಲಿ theta 1 ಮತ್ತು theta 2 ಬೌಂಡ್ಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ಏರಿಯಾ ಅನ್ನೋದು ಅವೆರಡು ಆ್ಯಂಗಲ್ಗೆ ಕರೆಸ್ಪಾಂಡ್ ಆಗಿರೋ ಲೈನ್ ಮಧ್ಯೆ ಇರತಕ್ಕಂಥದ್ದು ಜಾಗ. ಸೊ ಓಕೆ, ಈಗ ನಾವು ಈ ಫಾರ್ಮುಲಾಗಳನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಕೆಲವು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಕರ್ವ್ಗಳದ್ದು ಏರಿಯಾನ ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡೋಣ. ಸೊ ಒಟ್ಟು ಇಲ್ಲಿ ನಾನು 3 ಕರ್ವ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋತಾ ಇದ್ದೀನಿ. ಫಸ್ಟ್ ಒನ್ ಬಂದು ಟ್ರೇಸಿಂಗ್ ಆಫ್ ಕರ್ವಲ್ಲಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಲ್ಲ, ಸೇಮ್ ಕರ್ವ್ಸ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಫಸ್ಟ್ ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇರ್ತಕ್ಕಂಥದ್ದು ಸಿಸಾಯ್ಡ್. ಸೊ ಫೈಂಡ್ ದಿ ಏರಿಯಾ ಬೌಂಡೆಡ್ ಬಿಟ್ವೀನ್ ದಿ ಸಿಸಾಯ್ಡ್. Find the area bounded between the cissoid y square into a minus x equal to x cube, a greater than 0. Solution. ಸೊ ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ನಮಗೆ ಫಿಗರ್ ಬರ್ಕೋಬೇಕು. ಸೊ ಫಿಗರ್ ರೆಫರೆನ್ಸ್ ಇದ್ದರೆ ನಮ್ಗೆ ಈಸಿ ಆಗುತ್ತೆ ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೆ. ಸೊ ಇದು ಫಿಗರ್ ಬರ್ಕೋತಾ ಇದ್ದೀನಿ. ಫಸ್ಟ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಮತ್ತು ವೈ ಆಕ್ಸಿಸ್. ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಇದು ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ಸು, ಇದು ವೈ ಆಕ್ಸಿಸ್ಸು. ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಎ, ಅಸಿಂಪ್ಟೋಟ್ ಇರುತ್ತೆ. ಸೊ ಇದು ಫಿಗರ್ ವೈ ಆಕ್ಸಿಸ್, ಎಕ್ಸ್ ಆಕ್ಸಿಸ್. ದಿಸ್ ಇಸ್ ದ ಪಾಯಿಂಟ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಎ, ಅಥವಾ ನೀವು ಎ ಕಮ 0 ಅಂತ ಬರ್ಕೋಬೋದು. ದಿಸ್ ಇಸ್ 0 ಕಮ 0. ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಏರಿಯಾ ಇನ್ ದಿಸ್ ರೀಜನ್. Here the region lies from this point 0 to a. So that's what you need to identify. And one more thing, the curve is symmetric about x-axis. Whatever the area above x-axis, same area is there in the region below x-axis. So if you find the area bounded by the curve above x-axis, and if you multiply it by 2, you get the total area bounded by the curve. Since, okay, first let us write the given thing. Given y square into a minus x equal to x cube, a greater than 0. Since curve is symmetric, about x-axis, the total area is twice the area in the upper of plane. So if you write the formula, now you have to keep this thing in mind. So only upper of plane you have to keep in mind. So A is given by 2 into integral. See here the region varies from 0 to A. 0 to A f of x dx. अथवा 2 times of integral 0 to A y into dx. But we have y square into a minus x equal to x cube. From that, try to get an expression for y. It will be 2 times of integral 0 to a x power 3 by 2 divided by a minus x whole power 1 by 2. So square root of a minus x you can write into dx. So just we have substituted for y. Now to solve this integral, I will set this can be solved by the method of substitution. So set ಅಥವಾ ನೀವು put ಅಂತಾನು ತಗೋಬಹುದು x to be a sin square theta. Set x to be a sin square theta. Then dx will be 2a sin theta cos theta. And when x is 0, obviously theta will be 0. And when x is a equal to a sin square theta, a get cancelled, sin square theta equal to 1. So sin theta equal to 1, so theta will be pi by 2. So now a become a equal to 2 into integral 0 to pi by 2. X power 3 by 2 is a power 3 by 2 into sin square theta whole power 3 by 2 divided by square root of a minus a sin square theta into dx ಅಂತಂದ್ರೆ 2a sin theta cos theta d theta. Now here 2 get cancelled, and here a times of 1 minus sin square theta. So under square root a times of 1 minus sin square theta, that is actually a into cos square theta, right? So substituting those things, let us take constant terms outside. A will be 4a times integral 0 to pi by 2. Okay, a power 3 by 2 ಇದೆಯಲ್ಲ, so a into a power 3 by 2, that is a power 5 by 2. So 4 into a power 5 by 2 into 2 to get cancelled, sin cube theta into sin theta, that is sin power 4 theta into cos theta divided by ಇಲ್ಲಿ square root of a cos square theta d theta. So a equal to 4a power 5 by 2 divided by ಇಲ್ಲಿ square root of a ಹೊರಗಡೆ ತಗೋತಿದ್ದೀನಿ, a power 1 by 2 integral 0 to pi by 2 sin power 4 theta into square root of cos theta, ಈ cos theta ಜೊತೆ cancel ಆಗುತ್ತೆ, d theta. Right? Now using reduction formula, we will be having a equal to 4 into a power 5 by 2 divided by a power 1 by 2, that gives you 4a square into, for this applying reduction formula we get 3 by 2, okay, 3 by 4, sorry, 3 by 4 into 1 by 2 into, since you have n positive integer, multiplied by pi by 2. So 4 get cancelled. So finally you get capital A to be 3 pi a square by 4 square units. 3 pi a square by 4 square units. So that is the area bounded by the Cissoid curve. So next, let us discuss area bounded by the asteroid. Problem number 2. Find the area bounded by the asteroid. X power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. A greater than 0. ಸೊ ಯೂಶ್ವಲಿ ನಾವು ಆಸ್ಟ್ರಾಯ್ಡ್ ಈಕ್ವೇಷನ್ ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅವಾಗೆಲ್ಲ ಜನರಲ್ ಆಗಿ ಅದರದ್ದು ಪ್ಯಾರಾಮೆಟ್ರಿಕ್ ಫಾರ್ಮನ್ನು ರೀಕಾಲ್ ಮಾಡ್ಕೋತಾ ಇರ್ತೀವಿ. ಸೊ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಎ ಕಾಸ್ ಕ್ಯೂಬ್ ಟೀಟಾ, ವೈ ಈಕ್ವಲ್ ಟು ಎ ಸೈನ್ ಕ್ಯೂಬ್ ಟೀಟಾ. ಪ್ಯಾರಾಮೆಟ್ರಿಕ್ ಫಾರ್ಮ್ ಅಂತ ಬಂದಾಗ ಟೀಟಾ ಅಥವಾ ಟಿ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ಆ್ಯಸ್ ಯುವರ್ ಕನ್ವೀನಿಯನ್ಸ್. ಓಕೆ, ಇಲ್ಲಿ ಆ್ಯಂಗಲ್ಸ್ ಎಲ್ಲ ಬರೋದ್ರಿಂದ ನಾನು ಟೀಟಾ ಅಂತ ಬರ್ಕೊಂಡೆ ಅಷ್ಟೇ. ಸೊಲ್ಯೂಷನ್ given x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3, a greater than 0. ಸೊ ಆಸ್ಟ್ರಾಯ್ಡ್ ನಿಮಗೆ ಅದರದ್ದು ಕರ್ವ್ ನೆನಪಿರ್ಬೋದು. ಎ ಮೈನಸ್ ಎ ಮೈನಸ್ ಎ. So it is symmetric about x-axis and also symmetric about y-axis, right? The curve is symmetric about both x and y-axis. Hence the total area. See, if you find this area, the total area is 4 times this area. This is the point 0, 0. This is the point a, 0. The total area is 4 times the area in the first quadrant. 4 times the area in the first quadrant. So we get a equal to, capital A equal to 4 times integral 0 to a, 4 times integral 0 to a y dx. 4 times integral 0 to a y dx. We have x equal to a cos cube theta, y equal to a sin cube theta. Now from this I want dx. So dx is 3a cos square theta into minus sin theta d theta. Right? When x is 0, a cos cube theta 0, a cannot be 0, so that implies cos theta should be 0. That implies theta should be pi by 2. When x is a, we will be having a cos cube theta equal to a. So that implies cos theta is 1. So theta is 0. Now this became a equal to 4 times integral 0 iddaga pi by 2. So pi by 2 to 0 y, that is a sin cube theta, into dx, that is 3a cos square theta into minus sin theta d theta. Now this will be a equal to 12 a square, 3 into 4, 12, a into a square. See, we have this result. Integral a to b f of x dx is equal to, okay, minus integral a to b f of x dx is equal to integral b to a f of x dx. Okay, using that result, see, you have, if you interchange, okay, let us write one line, I mean one more step, minus 12 a square integral pi by 2 to 0 sine power 4 theta into cos square theta d theta. Now we have minus integral pi by 2 to 0, just like minus a to b. Now if you interchange the limits, this negative sign will be removed. So a will be equal to 12 a square, interchange the limits, integral 0 to pi by 2 sine power 4 theta cos square theta d theta. Now by applying reduction formula to this, we have a equal to 12 a square into 12 a square into 3 by 6 into 1 by 4 into 1 by 2 into, since both m and n are even here, multiply final answer by pi by 2. So this actually gives us 3 pi a square by 8 square units. So that is the area bounded by the asteroid. The last one we are going to consider is find the area of the Courtyard. Find the area of the Courtyard. R equal to a times of 1 plus cos theta. Obviously theta lies between 0 and 2 pi. Solution. Courtyard, I hope you can recall its structure. It is 2a comma 0. It is 0 comma 0 pole. And this is the line corresponding to theta equal to pi by 2. This is the line corresponding to theta equal to 0, theta equal to pi. So here theta varies from 0 to pi. Theta varies from 0 to pi, and curve is symmetric about the initial line. Given r equal to a times of 1 plus cos theta. Since the curve is symmetric about the initial line, the total area is twice the area in the upper of plane. In the upper of plane means theta varies from 0 to pi. So we have capital A equal to 2 times integral theta varying from 0 to pi r square by 2 d theta. R is given, r equal to a times of 1 plus cos theta. So a equal to, these two get cancelled with this, integral 0 to pi a square into 1 plus cos theta whole square d theta. So capital A equal to a square you can take outside, integral 0 to pi. This you can write 2 cos square theta by 2 whole square d theta. So it will be integral, okay, you can take 4 outside, 4a square integral 0 to pi cos square of theta by 2 d theta. Put t equal to theta by 2, then d theta will be 2 dt, and theta varies from 0 to pi, t varies from 0 to pi by 2. Thus we will be getting here capital A equal to 4a square integral 0 to pi by 2 cos square t 2 dt. So that is 8a square integral 0 to pi by 2 cos square t dt. Applying a reduction formula, this will be, okay, sorry, this should be cos power 4. Yes, applying reduction formula now, it is 3 by 4 into 1 by 2 into n is an even number, pi by 2. So we get a equal to 3 pi a square by 2 square units.